Right, so we're switching now into the code and play category of this chunk, and so let's go right down the line here. Who wants to go first? What's new this year? I guess we have...
We can start here.
Yeah.
Because Lego Boost is very new. We announced 2 days ago at CES. It's a new product line for Lego, and it focuses on adding behaviors to Lego built models so that the kids can actually make their models come to life for real through movement, sound, and light. And of course it uses coding as a platform to enable the kids to do that. And it's a new product. We're still developing it. It's not actually out yet. It'll be ready in August. And it focuses very much on one product where there's 5 models for the kids to explore, different play types, through the sort of the coding platform.
Bethany, what's new from Technology Will Save Us?
So we launched our Mover Kit and our Make platform the end of last year. And our Mover Kit is a wearable that kids have to build and code themselves, but it's all triggered by movement. So it's very much about being active. So attaching it to your bike, attaching it to your scooter, playing, being a kid really, but using code to unleash it so that you can use light as a way of creating games and activities. So you can make a bike like out of it, you can make games out of it, you can make toothbrush trainers. So it has an accelerometer, a motion sensor, 8 rainbow LEDs, and a compass that you can program to do anything. And I think the most exciting part about launching that was launching the Make platform in conjunction with that, which is basically our digital platform, which has a block-based programming language, which allows you to program hardware. And it also becomes the kind of central hub for all of our kids. So it has content, projects, community, a way to really help kids to save things they're doing, share things they're doing, and find new things to do.
Hansol, what's new with you guys?
So last year here at CES, we launched world's first programmable and educational drone called CoDrone. And then this year, we made it even, we are launching a new CoDrone Lite, which is even cheaper version. So this is the first under $100 programmable educational drone out there. So that's what we launched. It's also, you can program it with, it's very versatile platform, so you can program it with block-based program, you can program it with, or you can control it with computer, iPhone, or Android, and we provide all of the free curriculum on our website. That you
don't have slides, so I'm just checking.
Yeah.
Yeah, so programmable drone, and now I'm doing this very constructivist panel. Now I can go back and you can see what Simon was talking about with the robots, and then you can also see what Technology Will Save Us is doing, which is right there. It's really funny because the booth across from Technology Will Save Us is like a thing you stand on, and it's Technology Will Kill Us is right across from
Everyone's falling off.
It's so funny. You just go down there and get some, watch that, it's fun. So we, yeah, wow, Simon, look at, here are your slides. Do you want to?
Yeah, they seem to be here today. There was just one yesterday. So
use that clicker and...
We managed to get them back. So I'm not going to bore you by PowerPoint, so don't worry. I think we'll actually just skip straight to this one. So here you can actually see what I was talking about earlier about...
Yeah, so pay attention to this language because it's the same, you know, we've seen this in many products. This one is really silky smooth.
Yes, so this is our own language that we've developed in-house. It is based on Scratch Junior, so we do have a collaboration with MIT, Mitch Resnick's area actually in particular. So it's a very simple language that's been developed for a younger age of kid. As many of you probably know, we also have Lego Mindstorms in the portfolio. Mindstorms is a more advanced language, so we spent a lot of time in developing a language that's easier for a younger kid to understand, starting at the age of 7+. And by doing that, we've made a sort of a horizontal sequential language that's icon-based. So there's no text. The kids don't have to understand what a word might be meaning. They can just drag and drop these blocks and try them out. And of course, that presents some challenges. Some of the icons are very obvious, so the move blocks, which are the green ones, are pretty intuitive as to what they do.
Is Brian Silverman here by chance? In Artemis? If anyone spots him, let me know, because he's one of the architects of this whole idea of the blocks, and it's kind of really fun to see both tails of the end.
Exactly, and Brian has actually been a collaborator on this as well as with his Pico. Yeah, and some of the other icons are maybe a little less intuitive, but what we've seen a lot is that the kids will actually just drag them up, play them out, and see what happens. So there's very little sort of fear of failure in this approach to coding. It's very quick to do. Hopefully you'll see that a bit later in the demo. And it enables the kids to actually then create behaviors very simply. So we introduce them to groups of blocks at a time. They do a number of activities with the different models that they choose to explore. And then once they've understood a group of blocks, they can use them in their free play, so they're not restricted. They can actually use all the blocks that they accumulate as they go through the experience. So it's kind of like a game mechanic to keep them engaged in the experience. The other thing that we've made sure we've focused on very much is that, of course, and part of this panel is, of course, talking about coding being a learning and a STEM opportunity, an educational opportunity. And that's not the approach that we've taken with Boost. We want the kids to have fun first. So we want them to be engaged in the experience, and the coding is a byproduct of that. It's a means to an end for them to be able to give behaviors to their models. If they come out of this learning more about coding, that's great. And of course, any Lego product, they are learning some kind of creative skill anyway, whether it's in the digital world or the physical building world. But the purpose of this is just to give them the means to the end of the behavior building that they will have in their models.
Simon, can I suggest a different title for you? Call it Tangible Minecraft. Right?
Very good.
So how many of you guys have Legos in your attic or basement? Existing Legos. And so you already own this. I mean, this is, you can start, it's a platform that you can start programming, and so
yeah.
I think that's a really cool concept. And those are some of the things. I want to get to the products, okay? And I'd like each of you to show us one thing that is sort of a headline that you really want this audience to know about, and I'll turn on the document camera. Does that sound good?
Mm-hmm.
That's good.
All right. So, Hansol, you have anything that you can turn on?
So basically, I'm gonna show you really quick.
You guys can all start up your things. I want Bethany, we got to get that thing, a close-up of that flashing.
So I'm gonna just set this up right here.
Come down here.
So basically, our company, we started as an education company. So we have, this is just a website that's showing up right now. And then the idea is, when we were teaching students, it was very hard to have one teacher teach 10 students or 20 students at the same time. So what we did was we made very clear, straightforward, Khan Academy-like video instructions. So students will be just going on here, and then they'll be simply playing video that they love. They will be watching video for 5 minutes, and then after coding it for 10 minutes, drones will be flying. So we made robots before, and then we started making drones from last year. And when the drones were flying after their coding, they were going like crazy, and they got very engaged in the education. So let me just pair this, and then just FYI. Let me see. Sorry.
I liked it. Keep going.
Sorry. Just FYI. So I'm connecting it. There's when there's thousands of Bluetooth here, this may disconnect while it's flying. So I'm gonna hope this will fly and land, and then when it's supposed to land and stop right away. But there's a chance that it's gonna crash. But that's gonna be another good demo how durable it is. So let's give it a try. Oh, let me see. Oh,
Technology will save us.
Okay, let me see.
So you're just controlling it.
Yes. So basically, let me see. So this flies, and then when it lands, it stops.
Make them feel good, ladies and gentlemen.
Yay!
And then.
What is that?
Oh, this is the programmable module that they can do, so they can also control it to test how it works. And then the idea is the student will be programming it. After watching 5 minutes, they program it, and then I just connect it and control it. But our idea is having students fully autonomously control the drone, and the drone will be fully functional. They can do laser battle together. They can make it do obstacle avoidance, and they can do a lot of fun things with it.
Well, thanks. Let's go to Technology Will Save Us down here. And Bethany, let's see that thing that's flashing on your wrist. Get a close-up of that, because that's a good visual. But here are the kits. There's a synth kit, speaker kit.
So we have a range of products. All the kits you have to make, play, and code. Actually, not all of them do you have to code. I think similar to what Simon was saying about Lego, our interest is in helping kids to get hands-on with tech, to really feel it, experience it, play with it, quite frankly, gain confidence around their abilities with it so that they can make choices in the future as to how they want it to be a part of their lives. I don't think our end goal is to teach every kid how to become a programmer. I think our end goal is to create a generation of digital creators that are empowered with skills and confidence to figure out how they want to do and what they want to do with tech. And I think that's why our name kind of makes sense, because we actually fundamentally believe that kids empowered with skills and with tech will change their world and our worlds through that confidence. So that's why we have a range. It gives us range in both price and range in skill. So we have things like electronic Play-Doh, all the way to building your own speakers and designing them out of balloons, to things like the Mover Kit, where you actually do start to bring in things like programming. So like all of our products, you open the box and everything you need is in it. You actually have to build it, so you're really forced to, or confronted with real tech. You assemble it yourself, you put it together, you put the case on, and then you turn it on, and right out of the box, it essentially turns on. So this idea of a portable, responsive device was something that we did a lot of testing around. We do a ton of user research and tests with kids all the time. The thing they loved the most was something they could take with them, something that responded immediately, and light was this just wow thing, and something that they could do anything with. So they wanted open-ended opportunities. And so the idea of it being a wearable wasn't because we wanted to make a wearable. It's because kids wanted something portable. They wanted something they could do things with. So right out of the box, you can make things out of it. So you can make things like a bike light. So front light, back light, and it uses the accelerometer. Most kids don't even know there's an accelerometer in anything. Then right out of there, you can do things like move with it. So jump, spin, run, do whatever you want, and it unleashes different colors. And so kids are really being active, and every color then becomes something for them. So as a parent, sometimes I watch my son, and I don't really know why he's creating the rules and the things that he wants with these games. He's just being creative and inventing things. And so these different opportunities to run, spin, jump, ride your scooter faster, ride your bike faster, then unleash these different colors. And the platform is really about going through projects that other kids have made, that you have made. So in this particular case, you scroll through a bunch of projects. This little girl wanted to turn a remote control car she got for Christmas into a police car. So she programmed it to have red and blue flashing lights, not because she wanted to learn programming, but because she wanted to turn her car into a police car. Uploaded it quickly, and the faster her car went, the more flashing lights it had. And again, this idea of finding the thing you want and inventing the thing around that is the reason we include programming in this process. And I think one of my favorite projects that was created was the toothbrush trainer. So a little kid, he wanted to basically brush his teeth for 2 minutes and be able to show his mom that he brushed his teeth. So he programmed the accelerometer for 2 minutes, a certain speed, a certain duration, and when he was done brushing his teeth, he showed his mom, and that was his project for the day, and he uses it every day now. And I think those are the kind of everyday moments that I think are the most exciting for us. We didn't know he was going to do that. He just wanted to, so he did it. So yeah.
Well, thanks, Bethany. Simon, show us the coolest thing you can show us in like 30 seconds.
Okay.
That's cool.
All right, so this is Vernie. He's the main robot in the set, and what I'm going to get him to do is prank you.
Okay.
All right, so hopefully we can hear the sound. He's going to ask you to do something, and I'd like you to oblige.
Okay.
Hold my finger.
Oh boy. Oh Lord. You set a new standard here for kids to play.
We never underestimate in the project how popular pull my finger joke.
You know, that's why the Danes are the world's happiest people. It's
Yes,
true.
yeah.
That's the coolest thing you got?
Now I've got something else. I've got something else as well. So part of the concept is that obviously, as you can see, Vernie is built out of what we call classic Lego bricks. Mindstorms, to give the comparison, is Technic based as a platform. And all of you that put your hands up saying you had Lego bricks in your attic, it means you can use those bricks to actually build accessories for Vernie. You could actually, as part of the experience, build your own models and make them come to life. So part of the experience that we've made sure that we've curated is that throughout the app, and everything is contained within the app, including the building instructions, there are little mini builds through the experience. So the kids aren't always coding, they actually do a little bit of building and get their hands on the bricks, and then they go back to actually applying some accessories to Vernie or the other models, and then using those to actually change his personality physically, as well as then they can change his personality digitally in the app. So we have some little accessories to give him. So we're going to give him a little bow tie. And in his hands, you can see that you can actually open his hand. So we can give him a little microphone. And now he's going to be a stand-up comedian. So he's going to tell a joke.
Oh boy.
Why do dolphins live in salt water? Because pepper would make them sneeze.
So, and this is actually why we're not ready for launch, is because our jokes, we still need to work on our jokes. Yeah. But,
So our children are in the hands of some great minds here.
But just to show, this is how the code works. So these are some of the things I've actually set up for him to do. We can also get him to do a little move forward and a spin. So he's highly mobile as well in how he works. And it's very easy drag and drop coding. So at the bottom here you have some panels where you have lots of little blocks that you can pick up. And you just literally drag them up and then apply them to one of these play triggers. And then you can actually start to do some simple little coding.
This is fun.
So if we bring up this, for example, and if I press this, he will shoot his target.
Did you see that? That was so fast I couldn't get it on camera.
Okay, well, I can get
It's
it
a
now.
fun.
And this is actually a really good example of showing how we can use a combination of sound and movement to actually make this more impressive than the actual shooter is. This is a shooter that's been, and you can see it here on his shoulder. This has been in development in many products.
Can you shoot Technology Will Save Us? He's right over there.
Like shoot me, like
Is that
physically?
fair?
I want to see if Technology will save her.
I'd rather,
No, shoot Rachel. She needs to be shot. Yeah,
beforehand, Rachel, I am sorry, but there you go.
got her.
So when you saw Vernie shoot, there was a sound, but he also recoiled. So there's all those combinations of actual lower level code that we put into that one block. So it means that the kids don't have to worry about making him do all of that stuff. He does it automatically.
So the brain there's a common denominator is this white block inside of there. So go down and look at all the sensors and so on, and it's at the booth.
Yes. Yeah.
And Technology Will Save Us. You got a great booth. You can see all the things. And you guys have a booth?
We are right next to Lego as well as Sense.
Oh, awesome.
Yeah.
Good. So guys, get your hands on these because playing with them and actually try them is the way to understand them. It's been amazing to be able to have the CEOs and main brains behind these products here today. Let's give them a round of applause and bring up the next panel.